whatever you need. And I started my video. So types of discontinuities, how many and which ones? Anyone? How many and which ones?
Sure.
So there are three different discontinuities, and they are
Jump. Removable. And infinite discontinuity.
excellent. Continuity at the point. The definition of continuity at the point, please. Anyone, please? Definition of continuity at the point.
When the limit of f of x from the left equals the limit of f of x from the right, which equals the
function value at that point.
evaluation. Yeah,
Excellent.
that.
Good. Perfect. Condition for continuity from the right. Tom, Mason, Landon, Aaron, Dakota, anyone, please. Condition for continuity from the right. Anyone, please. Yes.
That be the limit of f of x as x approaches a from the right equals the function of a.
Brilliant. Thank you so much. Awesome. Condition for removable discontinuity, please. Thank you. Anyone, please. Condition for removable discontinuity.
That would be limit of f of x approaching x from or a from the right or whatever, and that equals the limit of f of x approaching the right.
But the only problem is that it does not equal
Yeah.
the function value. Awesome. Great. Thank you. That's all I needed. The floor is open for any questions. Anything you want me to go over? Anything you'd like to discuss? Anything? Any questions, please? Any questions from anything we studied? Really, anything? No
I have a question on web assign.
Yes, I'm ready.
On 2.3.
Yes.
It has us, it says the graphs of f and g are given. Use them to evaluate each limit if it exists. And then it's got some of the
Is there a graph that I have to look at?
Well, yes.
Okay, which number is it again?
Number 2.
Very good. Let me share my screen. Let me find it. And you said 2.3.
Yes. And I thought I was doing it right, and then it marked it wrong. So I just wanted, it's like a 6-part question, and I got half of them right and half of them wrong. So I just needed clarification on like the first 2.
I meant to share the screen and I didn't mean to change anything. So here it is. Is this the one?
Yes.
Okay. Are these the same graphs, or do I have to go to your?
No, those are the same ones.
Okay. So here we're asked to find the limit of f of x plus g of x as x approaches 2. The property that we know is if both limits exist, if they both exist, then I can, if the limit of f of x and limit of g of x individually, if they exist, then I can use the property or the rule, the limit of the first plus the limit of the second. So let's look at, so did you get the first one correct?
Yes, I Now I know what I did wrong. I'm sorry.
That's okay. So the limit of f of x as x approaches 2. So here's the x-axis, and here is 2. The limit for f of x is 2. So the first one, limit of f of x as x approaches 2 is 2. Now I have to look at g. The limit of g of x as x approaches 2. Here's 2. Here's the x-axis, and this is 0. So 2 plus 0 will be 2. Next one. They want at 1. The same question, but at 1. Okay, so at 1, this is 1. And at 1, the limit is d and e. So 1 plus d and e is d and e. Should we continue?
Hold on. Can you go back and say A again? You said 2, but why is it not D and E for A?
The limit as x approaches 2 for f of x is
Uh-huh.
here. We're not asked for the function value. We're talking about the target. When
But
x approaches,
isn't there, wouldn't you say D and, oh, never mind, because there's discontinuity there.
it doesn't matter. The limit,
Okay.
okay, let's talk about this again. The limit of f of x as x
Mhm.
approaches 2 does not mean f of 2. These are two
Right.
different concepts. This one says target.
Mhm.
This one says value,
Right.
evaluate. So we're not looking at this.
Okay, but
We're
since
looking
f
at
of x-
this.
Right.
So when we look at the target,
Mhm.
the target is 2. From the left of 2, the target is 2. From the right of 2, the target is 2.
Mhm.
We're not asked to find the function value at
Right.
2. The function value at 2, not even that is undefined. It's 1.
Mhm.
But we're not asked to find the function value at 2. We're asked to find the limit as x approaches 2.
Target from
So
each
it's
side.
2.
Gotcha. Okay.
Now, for 2 on the side is 0. So 2 plus 0 is 2. But the next one, the limit as x approaches 1 from either side is 1. But the limit as x approaches 1 from either side of g is d and e, because the limit from the left is 1 and the limit from the right is 2. So 1 plus d and e must be d and e. Is that okay?
Yes. Thank you.
Okay, do we need to continue?
No.
Which one you needed help with? So let's take a look, the one you needed help with.
It was A, B, and then E, but once you said that, I figured out E, so I'm good now.
Okay then, perfect. Excellent question. Thank you for bringing that up, because many of your colleagues did not look at it, not even looked at it. So it's very helpful. Thank you for your question. Good. Next one. Anything else? Other questions? Anything else that you want to work on? Okay, in that case, we will continue. The next section that we have to look at is 2.6, and that deals with limits at infinity. So, 2.6. So let's try to understand, first of all, two different concepts. One concept is called infinite limit, which means the limit is infinity or negative infinity. So the limit of a function as x approaches a is infinity or negative infinity. This is what it's called, infinite limit. If this is infinity or negative infinity, then x equals a will be considered what? If this happens, x equals a will be considered
The vertical asymptote.
Thank you very much. Awesome. This we discussed. Now, see the difference. Limits at infinity. It's a different story. Limits at infinity mean limit as x approaches infinity or xx approaches negative infinity of f of x. If this is a number, let's say a, I'm sorry, I don't want to use a because I don't want you to get confused. It's not this a. So anything, L, let's say. And if this is a number, right, if it's a number, then y equals that number is a horizontal asymptote. So see, these are two very important concepts about functions, but they are totally different. This one says infinite limit, which means the result is infinity, which gives us the vertical asymptote. And limits at infinity, which means x approaches infinity or negative infinity. If we get a number, but we don't have to, it could be infinity, result can be anything. But if it is a number, y equals that number is the horizontal asymptote. So we want to work on these situations. I am going to share my screen, hopefully find the book. I thought I had the book open. Where is my book? Here's my book. Okay. And we go to 2.6. There are many different situations here. So limits at infinity, horizontal asymptotes. So we're going to go through different, no precise definition where I'm not asking you to do any of that. The precise definition or epsilon delta just for linear functions. Okay. So let's look at a couple of graphs first. Okay. So here's a graph. And I'm going to ask when x approaches negative infinity, where is the function going? What is the target of the function when x approaches negative infinity? X approaches negative infinity. What would you say?
It looks like it's approaching 2.
Awesome. Great job. I'm going to stop and just write that. So the limit as x approaches negative infinity of f of x is 2. This means, again, the target is 2. I'm not saying that the function will touch 2. No, I'm only saying the target of f of x is 2. Which means y equals 2 is a horizontal asymptote for this problem. Awesome. Thank you. Great job. Thank you. Okay. What about the limit as x approaches infinity?
-2?
Yes.
Y.
Yes. So f of x equals -2, y equals -2 is a horizontal asymptote. Awesome. So I will say the target of f of x is -2. Who knows if it touches it? We don't know. This operator says what is the target. Reachable or not, we don't care. The target is -2, which means y equals -2 in this case is a horizontal asymptote. Awesome. Good job. Okay, moving on. Same thing here. As you see, it goes up and down, but it stabilizes at 2. Goes up and down, but it stabilizes at -1. Very clear. Okay. Now I would like to practice a gibberish that I call gibberish. They're getting more and more difficult, you'll see, throughout the semester. Except chapter 5, 4 and 5. They're not in chapter 4 and 5. We're dealing with something else then. So let's pick a gibberish and analyze it, summarize it, and graph a function. I'm ready. Please pick anyone.
We can do 8.
8. We want to work on 8. Take me a second to copy it down. Make sure I copy it correctly. Limit as x approaches -8 of f of x equals -infinity. Limit of f of x as x approaches 2 from the left is infinity. limit of f of x as x approaches 2 from the right. They say is negative infinity. Limit of f of x as x approaches 2 is infinity. And limit of f of x as x approaches infinity is infinite. Thank you. Good pick. Again, gibberish doesn't mean anything to me. I don't even know where to start. I want to organize my information. I will not just play it by ear. It's not a good idea. And also, I practice the table, which is, you'll see the table is invaluable later on. So please understand that. Okay, so I see a function that goes from negative infinity to infinity at f of x, the x value. So now, the limit of f of x as x approaches negative infinity is negative infinity. Okay, fine. This is done. Now we're talking about 2. So 2 from the left, 2 from the right. Is this correct? Did I copy that correctly? Sometimes I copy from 2 different. 2 from the left is infinity, 2 from the right is negative infinity, and from either side is infinity. Okay, so that's not possible. Absolutely not possible. It cannot, from the left, there is an error here. There is a typo. From the left approaches infinity. From the right approaches negative infinity. But then from either side approaches infinity? No. Sorry, not possible. I don't know what they meant. I think they wanted something else here. So this is not doable. So I'm going to write it so you understand what I'm talking about. Again, so 2. 2 from the left is infinity. So 2 from the right is negative infinity. This is impossible. They meant something else. I'm going to make a correction. 3 or any other number. Tell me what number you want to put in there. Doesn't make any sense. You understand why, right? The limit from the left is infinity. The limit from the right is negative infinity. I cannot insert here infinity. It's not possible. So would you prefer 3 or something else?
Yeah, 3 can work.
Okay, perfect. So 3, now this is clear. This is possible. No problem there. And they also say that when x approaches infinity, the limit is infinity. Okay, I'm going to change that and put it further to the side, to the right. Now this makes sense. So, obviously, if on the left-hand side of 2 and the right-hand side of 2, we have infinities or negative infinities or both the same, it doesn't matter. We know that x equals 2 must be a VA. Absolutely the same thing here. It just that on both sides is positive infinity, so x equals 3 must be a VA. Since this is not a number and this is not a number, I will say no horizontal asymptotes. None. If this is 5, then I have y equals 5, a horizontal asymptote. If this is negative 3, then I have a horizontal asymptote negative 3. But if these two are infinities, no horizontal asymptotes. Okay, so now we're ready to graph. When we graph functions with asymptotes, what do we need to graph first?
The asymptote.
Yes, thank you, thank you, thank you. So x equals 2. And we write x equals 2, so it's clear. It's not part of the graph. It cannot be a solid line. And x equals 3. Perfect. Now, the function is coming from, sorry, negative infinity going to positive infinity on the left-hand side of the first asymptote. Okay, no problem. coming from negative infinity, going to positive infinity on the left-hand side of 2. On the right-hand side of 2 is coming from negative infinity, and it's going to positive infinity. Okay, fine. So on this side is coming from negative infinity, but on the left-hand side of 3 will go to infinity. And then here, from infinity to infinity. From infinity to infinity. It must have a minimum. There is no other way. A function cannot connect infinities. If it connects infinities, there must be a minimum somewhere. So this is my example, and you can make up your own. There is more than one correct answer, of course. Good pick.